morning, afternoon, or evening to wherever you are in the world. My name is Jared Dugan, and welcome to my Enterprise DNA session on data in the energy and resource industry. Before I dive in, I wanted to give a quick overview of what I'll discuss today before at the end answering any questions that I can. As someone who has transitioned into data from within the engineering and resources industry, I wanted to give a brief intro into my background and what I do, and then give a little context around what I see was the light bulb moment that made me dive into the world of data analytics and visualization. I'll then talk briefly about data analytics through the life cycle of the industry as I see it, from the inside looking out rather than the other way around. And then finally, for the practical part of this presentation, I'm going to examine how we look at data around the future energy transition and use that to identify long-term opportunities and potentially positioning for companies involved in or investing in energy and the resource industry. Okay, so I am actually an engineer by profession, but not a data engineer. I'm a rusty civil engineer and an even rustier geotechnical engineer. I've worked in design and construction for well over 15 years, primarily initially in the UK and Ireland before moving on to the UAE and Qatar, and then more recently in Japan and Australia. Initially, I worked mostly in large-scale infrastructure, roads, bridges, tunnels, urban utilities in the Middle East, but the majority of my career has been in the energy and resource sector. I spent just over 10 years as part of the prime contracting team on the Ichthys onshore LNG project in Darwin, Australia. That saw me starting at early engineering and procurement in Japan through to on-site construction management, commissioning and handover to the client. I'm now in my second year working as a non-process project manager on the Arafura rare earths mining project here in Australia, which is looking to mine and process NdPr oxide. Okay, so I digress slightly. So back to my light bulb moment with data. And now you might say, okay, you have this experience in design, infrastructure, etc. But what has that got to do with data analysis and visualization? Well, actually, it's a good question. It was towards the end of my time on the Ichthys LNG project, where like many major projects, you start to get sort of legal cases mounting, you may get arbitrations and things like that. So I was in 2018 initially asked to assist on one of two sort of high profile arbitration cases, which would eventually run over roughly 3 or 3.5 years and contest sums that ran into the billions of dollars rather than millions. So it was quite a sort of a big deal. As someone with a relatively long history through several roles on the project and working with the various joint venture partners, using the very different systems and platforms that they use to manage the project, I was asked to sort of almost be like an assistant to the e-discovery and data team to try and identify and source different types of project records from the different systems and databases that were used on the project by all the partners, so that they could be used by both our internal teams and if they were requested by the other side. Anyway, I spent, as I said, 3 years and 2 arbitrations, which involved the exchange of large amounts of data and records. There'd often be sort of disagreements over the types of records, volumes, completeness, duplication, etc. And when you think about it, if you have these large scale projects where you might have, in this instance, construction on site for almost 7 years or over 7 years, and at the peak I think there was like 8,000 people working on site every day, the amount of data that's collected and generated and stored becomes quite daunting when you look at it. For example, you could have a drawing database with 800,000 drawings in it, and each drawing has up to 300 pieces of metadata attached to that one document. You could have, defects databases from different vendors, hundreds of vendors around the world, where they're picking up defects on the products, or even things like everyday swipe card data for people coming in and out of site that gets collected, and the amount of information and that's stored in those sort of like SQL type databases becomes quite enormous. This type of information may be requested or used as part of an arbitration, and with such numbers and volumes of data, it soon became apparent to me that I would need to use almost a combined skill set of knowledge on the project with engineering and systems that were used, and then also my sort of fastly developing knowledge of analysis and visualization, that I could communicate with the different parties and stakeholders within the various teams to enable them to provide like a narrative as to what is this information, both qualitatively and quantitatively. This type of analysis in terms of stakeholders, you might want to be communicating with your own internal legal teams, with your own counsel. When you're presenting it to the other side or disclosing it to the other side, you may need to give a description or a breakdown of what's contained within the information. Or when there were sort of case management conferences and things like that, you need to be able to communicate it succinctly, and both succinctly and with detail to the panels who were leading the arbitration, so the sort of the judges who were sitting on that. So as these cases progressed and data and documentation became more important, I went from someone who was sort of working in the background, sort of giving this sort of brief advice or locating documents, to almost being like the data or stats person. And I ended up having to fly with the legal teams to most of the case management conferences in Singapore and Sydney, to effectively be there as like a fact checker on any statistics or document issues that were being raised or disputed. And then eventually I had to submit various witness statements to try and support sort of the data that was being disclosed, maybe analysis on the data and visualization to support that case. Was also sort of called upon to support any submissions, any applications or any correspondence where there was data that needed to be described or visualized or talked about. I was usually brought in to help out with that. So it was definitely a different experience from my normal job in sort of engineering and project management. But it was this process together with diving into the internals of all the data sets that were being used and collected on a major project like this that kind of opened my eyes to ways in which the sort of resource and energy industries, they collect a lot of this information and data, but they don't actually use it for much benefit, even though it's at their fingertips. So it was then that I took an interest in kind of finding ways to use the data information that is being collected and ultimately use it sort of to benefit the work that I do and hopefully others as well. So next, basically moving on to the resource itself and data. So like what could the industry be doing more of or better? So construction and resources are sort of slowly waking up to the uses of data in their work. Even in the last year, I think there's been quite a significant movement forward. As I mentioned, they collect a lot of information that they maybe don't actually use effectively. They may be behind other industries like finance, insurance, pharmaceuticals, etc. But there is a huge untapped potential out there, particularly in the construction phase, that if I was like an external data consultant, I would look to see if I could get into, because there's a large market there, and you've got plenty of clients. For the life cycle of energy and resources, I would maybe look to break this into sort of 3 stages. Sort of stage 1 or phase 1 may be that you're looking at trends and opportunities, or you might want to call that sort of business development. So if you're involved in the industry, either as an owner, a supplier, or a contractor, you'll want to know how energy and resources are pivoting in the future, especially now with the energy transition and push to net zero. Companies will want to know where they should be focusing their time, their resources, or the development of their personnel, and what the likely timeframes are. So in the industry, we can use forecast data trends from either individual researchers, government departments, or other sort of energy companies that specialize in it. The next phase you might want to see is like design and construction. And this probably has the widest scope in terms of the use of data. If you talk to many construction and project managers, they'll tell you that every project boils down to basically three things. It's budget, deliverables, and schedule. So this is the essence of project controls, where you want to track the cost or the budget, the schedule, how long it's going to take you, and the deliverables. So what is it that you actually have to hand over? So tracking and reporting on this data is actually relatively mature, although it's not very aesthetically pleasing. So it's kind of, you know, fit for purpose, as we would say in the industry. However, there are many other aspects of projects which may get neglected from a data usage point of view. This includes things like health and safety, which is very important, contract and commercial management, things like quality control, environmental and regulatory approvals, and also risk management. However, I say that they're kind of neglected, but this is slowly changing. So I've read things like companies like Oracle, they're using construction intelligence and predictive AI and sort of natural language processing, or NLP, to make predictions on things like delay or a contractor claim. They sort of look at the language being used in letters and emails, and they can sort of make a risk assessment on, you know, what's going to happen in the future based on the language that's being used. Also, I've seen like the likelihood of an accident occurring on site. So they would use health and safety data on where accidents are occurring. They would maybe look at, you know, the density of people working in a particular area, the time of day, temperatures. They might want to look at the type of activities that were taking place, the mixes of different types of tradespeople on site, whether it's, you know, concrete workers or, you know, steel fixers or, you know, boiler makers, etc. So they can make a prediction on which areas on a project on a particular day are going to have a higher risk of an accident occurring, and then you can deploy your supervisors to those sort of what are seen as hotspots to then more effectively sort of supervise and monitor that activity that's going on, to hopefully then try and reduce the actual occurrence of an accident. And then finally, operations and maybe maintenance. So once projects are complete and they become operational, data analysis primarily turns to operations, logistics, and maintenance. So whether it's a power station, mine, processing facility, or LNG facility, it'll normally include multiple processes and hundreds of pieces of plant and equipment, vessels, etc., that require continual monitoring, optimization, and maintenance. So this type of data analysis is more specialized maybe, and requires maybe more technical input from within the industry. It typically uses very large data sets, and maybe from previous projects or other projects where they gather data to create almost like an ML or an AI predictive modeling, where they can forecast, you know, the life of pieces of equipment based on, you know, sort of multivariate analysis on temperature, vibration, you know, how long it's been in use. So they'll monitor all these variables over time, and they can predict, you know, when things need to be changed out or shut down or whatever, with fairly good accuracy. So that's like an ongoing sort of data analysis tool that would be used in operations and maintenance and resources. If I move on to the more give an overview of the sort of the practical part that I'm going to look at today. So this involves looking at using market research to look at future trends. So this type of analysis might help a company, you know, pivot or focus on work in the future, or just provide maybe a little bit of a direction on further research that they might want to take. It may be simply that you're a contractor looking to work on particular projects. You want to see what's coming up in the long-term future. You might be a supplier looking to sell products and solutions. You might want to know where in the world you should be focusing your sales, or, you know, what type of energy you should be focusing on. Or if you're an investor, you might want to try and identify markets, companies, and stakeholders that you want to engage with as part of business development. Probably even taking a step back more strategically, if you were looking at the types of energy that were coming up in the future, you might then sort of connect that to the type of resources or minerals that are needed to support that particular energy industry in the long term. And then you might want to then develop or pivot your company towards that. For example, you might look at, I think I've got one up here, electric vehicles, wind or solar. You'll see that there are large amounts of minerals that are required. If I look at the project that we're working on, the NdPr rare earth mineral, so it's like a strong magnet and it's used in motors for electric vehicles. I think it's probably down here in the others, and it's also used in wind turbines as well. So here in Australia, like, there's the potential to become a key supplier of these minerals. I think West Australia is already the leader in the world in the supply of lithium. As I said, the data source that I'm going to be using is from DNV, who are sort of experts in risk management and the maritime and energy industries. I worked with them before on the Ichthys LNG project, and their latest research data contains information on various parts of the energy transition from 2020 through to 2050. Okay, so this is the data set. If I look from DNV Energy Transition Outlook 2022, there's a lot of information in here about demand, transport, different types of vehicles, different types of energy demand, manufacturing, hydrogen, grids, etc., etc. So there's a lot of information included in here. That's part of the problem, is trying to isolate and identify information that we want to know. As I said, I might want to try and maybe define what it is that we want to look at, or what I'm going to look at anyway. So I'd have a few questions, things like, what's the timeline for a transition from sort of fossil fuels to sort of renewables? That might be one question. Another one might be, how do we see the demand for particular types of energy change over time, and whether that's affected by region? What are the forecast expenditure on energy projects and infrastructure? And then, what's the tipping point? When is more money going to be spent on renewables versus fossil fuels? And then even things like energy costs. If you're looking at the sort of cost per kilowatt hour, gigawatt hour, whatever way you want to sort of calculate, what's the future cost if we're looking at fossil fuels or renewables? Is there going to be like a reduction in cost or an overall increase in cost? And then you might want to look at things like individual industries. So I think in this example, I'm going to look at electric vehicles. You might want to see, what's the trend over time for EVs and the uptake around the world in particular regions, and then how this would sort of flow into the slide that we looked at there previously about, for electric vehicles, the amount of mineral resources that are required for each vehicle. Okay, so that is enough for me looking at the sort of background. So let's get actually started into the work. Okay, so I won't go too much into like the steps of cleaning and managing the data set, but maybe just to have a quick oversight of what's included in here. So we have a dates table where we have the years going from 2020 through to 2050. We also have the regions. So within the data set, we have sort of named regions, sort of these abbreviations, and then the region name. I've also got these lookups that we're using. It's more just to categorize sort of the energy types into either the fossil fuel or renewable, and the same for demand, things like the types of energy, whether it's an energy or transport. Again, it's just for classification. Again, for economics, whether something is classified as CapEx, which is capital expenditure, or OpEx, operational expenditure. Things like power type, again, if it's renewable, fossil fuel, or nuclear. Again, same for primary energy. And then storage type, if we wanted to look at that at any level, the type of storage, and maybe just a short name for that. I brought in several of the tables from the DNV dataset. Typically they were the sort of wide tables. So what I've done is to make them sort of long and thin by unpivoting. So basically, if we have one like that, just basically promoting the headers, and unpivoting the data. So we have these long thin tables of, we have a variable that will have information on it, and then years, and then the value itself. So we've got one for primary supply, power economics. Power economics, sorry, is if we're looking at the cost of energy. Energy economics is, the construction or capital expenditure in building projects or maintaining them with operations expenditure or OPEX. Things like demand. Then we also have electric vehicle market share, the percentage across different areas for commercial and passenger vehicles. And electric vehicle stock, so how many vehicles are in circulation in different regions around the world, whether it's electric vehicle or internal combustion vehicle. So these are the sort of tables that we brought in, main tables, our lookups, our regions, and our dates. If I then quickly look at our model, it might look a little bit crazy, but we basically have all of those data tables that are connected into a date or a region, just so we can have that as a common reference, and then the various lookups that we're using just to categorize. So it's fairly basic. There's nothing too complicated in here. I've created these measure tables that we'll probably have a look at later, where we're creating measures and putting them into folders based on what we're going to be looking at. So I just thought I'd give a brief overview of how we've brought the data in, how we've structured it before we jump in to do the visualization. Okay, I just had to switch my camera to the top right or top left, maybe it is, just so that my head wasn't getting in the way of work. Okay, so we'll jump into this. What I want to do is answer our first question, which was along the lines of, what's the timeline for the transition from fossil fuels to renewables over the next sort of 25 to 30 years, and is it the same across the world? So what I wanted to do in our primary energy, sorry, if I drop that value in here, and then we have our dates, and I want the year across there, and then our legend will be our primary energy type. So I drop that in there, and then what I want to do is have a number of small multiples, and if I go to small multiples and I try, 2 by 5, and I take out our regions, there's a blank showing there, so I get these 10, and then for the years it might be a little bit too sort of clustered in there, so maybe I want to just look at every 5 years, just to give me a general overview rather than seeing every single year. And now I probably want to just change those colors, so I'll put a fossil fuel, maybe a renewable, and our nuclear, which is sort of falling in between. I don't like that color too much. I'll leave it. And then probably just to make this sort of sit out a little bit, I like just to drop in a bit of a background. So it gives us this, actually I'll change those colors, I don't like them. So for example here, if we want to look to see, we have fossil fuels, which is this sort of light blue, and then renewables, which are this sort of green color. We can see in Europe, between 2020 and 2050, there's a gradual sort of shift towards renewables. In the Greater China region, again, sort of following suit, maybe slightly lower percentages, but again, sort of following suit. Indian subcontinent, maybe slower again, quite similar to Latin America. We see Middle East, North Africa is sort of lagging behind a little bit. Okay, so that kind of gives us our general trends. Then if we want to look at the type of energy, again, we just drop in our primary. Again, I want to put in where's my dates here. What's that I want to show here? It's my primary energy value, primary energy source in the legend. So we get that in here. I want to make this sort of stand out a little bit more, so I'll drop this in, push it to the back. And then what I probably want here is some sort of a rudimentary slicer on the primary energy source. I can keep it like that, or see if this works. This, I don't really like this too much, but what I want to do here is edit the interaction. So I don't want this to be filtered by this primary energy source, but I do want this to be filtered. There is something that I want to show which you're not able to do sort of inbuilt inside the sort of standard visuals in Power BI, but I think probably something like Deneb can do it, which is sort of highlighting individual values. So if I've already looked at this sort of in advance. If I look at this, I think it's 20,000, maybe 200,000, sorry. And I copy this, and if I take that and remove the interaction, and I go to that, and the lines, I make them all sort of this, is it light gray, is it? It's a little bit of a pain, but I think it works quite well as sort of a general workaround. And then you just have to push it to the back, it disappears behind this. So push that to the back again. And then hopefully this works where you're able to do this sort of highlighting of different types. So again, yeah, you just need to make sure that the y-axis values you have set in both, otherwise it'll sort of recalculate, and then that that interaction is edit interactions is turned off. So that's kind of, this is answering my first part, which is, you know, what's the overall timeline and the type of regions where there's going to be a transition to more renewable than fossil fuels. And then as a primary energy source, if we look at natural gas, coal and oil, they are still, even by 2050, they are still being used as a primary energy source quite heavily. But for wind, geothermal, solar is increasing, things like biomass. There's more more types of renewable energy, and that sort of cumulative effect is then looks like it's sort of going to overtake fossil fuels in the next sort of 20 to 30 years. Okay, for this one, there's going to be a few additional calculations. So we have a total demand in terms of petajoules per year. Okay, renewable demand equals calculate total demand per year, or we want to filter that by our demand carrier energy type is equal to renewable, and just copy that because we're going to use it for our fossil demand. Fossil fuel. And then our new calculation will be the deficit. It'd be good if I knew how to spell deficit. So this is basically the renewable demand minus the fossil demand. So it's kind of like, you know, when do we cross that threshold of when renewable is more than fossil demand. So there's three sort of key calculations that we want to know. I have one or two sort of bonus calculations that I'm going to just copy in here and just explain. So if we want to know what's the average yearly change in the demand for fossils, for fossil fuels, if we take variables of, you know, this year 2022 and 2050, we want the difference. If we want at the end of 2050, you know, what's the fossil demand at the end, and then what's the fossil demand current year, and then basically just dividing that. So it's just an average yearly change in the demand. So we can have that for our fossil demand, and then we can also have it for renewable. And one more, which is just the total change in demand over a year. So maybe we just want to see, is there more demand for energy, or is energy demand decreasing in the future? Okay, so quickly gonna drop in a slicer for our regions on the top. Just decrease the size, padding. I think that should do. Take out this blank. So we'll use that as a basis, and what I want to put in here is a line chart to show over time what is the demand, total demand. And so if we want the total demand per year, let me just drop in year first. So total demand, and then renewable demand, and then fossil demand. So we'll see that in here. And then what I want to show in here is the deficit. So if I drop in renewable deficit and the year, I can see how that's going to change over time for a particular area. Again, just to make this pop a little bit more, I'll drop in a background. And then if we want to show just if we want to show a couple of cards, we can here. So we want to drop in our average total change. So what's our average, or what's our total demand? So for in Greater China, there's a apparent over the next 30 years, on average, will be reduction, although we see there's going to be a peak later on. But if we look at it overall, and then if we look at the average renewable, so we see, okay, there's a decrease in demand for energy overall, but there's an increase in renewable energy, and then there's the average yearly fossil change, or fossil fuel demand. So fossil fuels going down. So we might want to know why it is that there's this drop. Is it because there's less demand, or is there some sort of change in population or something like that? So we have a couple of calculations that we can drop in here. So if we want to know the average yearly population trend, again, it's similar to the one I was using here for energy, but we just replace the energy with population. So I can drop that in there, and then copy and paste. I've got another one which is a total population change. So again, looking at the start and the end. So if we want to see here, this is showing Greater China. So we've got that's happening. If we want to look at Europe, again, we see this change from renewable to fossil demand in sort of just 2038, I think it looks like. Again, we got a decrease in population over time. We've got this transition of a deficit from fossil to renewable, as you said, around about 2038. If you look at the Indian subcontinent or the Middle East, again, it's different. So there's positive population changes. So you can sort of filter around here and look at the different areas and see how energy demand is changing over a year, and maybe how that's affected by population. Okay, so next I want to just create probably just a more exploratory table matrix down here, demand carrier, sorry, and I drop in the energy type and the energy carrier and the years across the top, and then the total demand. Measures demand, total demand. So a little bit of filtering and go minimal. This we want to show 0 in our values. If you drop our font size down, sorry, drop it down. so we can fit everything in here. We're looking at this. We want a background color that's not as bad as that. Maybe slightly more defined. So we can see basically over time, if you want to look at particular types of energy, whether it's coal, natural gas, or oil, you know, what are the key players. So you can see here, if you want to look at Europe, for example, you can see that oil and natural gas tend to sort of fade out then, and then you're getting more sort of other types of energy that are coming on board later on. But as I said before, it's more a combined mix of different types of energy, rather than one particular type. Okay, so I'll try and move through the remaining ones as quickly as I can here. Okay, so I've moved to the energy economics. This is probably more interesting than probably supply. I'll come back to that later. So we have quickly gone ahead and created a couple of calculations. So we have our overall value. I wanted to know the spend on fossil energy, and also on grid energy, so how much it takes to build or maintain the energy grid in a region, and then also non-fossil energy, which effectively is renewables. And then also I wanted to calculate the sort of, as a percentage of the GDP, you know, what is the calculation spend? So in a region or a country, how much of their GDP are they spending on energy? So again, probably a couple of simple charts in here. Again, I'll drop in the year in the y-axis, and what do we want to look at? We want to look at year in the x-axis. Again, I'll drop in this background. Make this a percentage. So again, we see, you know, at the beginning of 2020, average expenditure is 3.26% of GDP on energy. But by 2050, that's going to drop to 2% of GDP. So there'll be less spent on energy development in the next number of years. And then we want to look at, you know, how is that sort of how is that maybe broken up? So again, we drop in the year in the x-axis, and then what do we want to look at first? We want to look at fossil expenditure, maybe, and then maybe grid expenditure, and then maybe non-fossil expenditure. So if you want to see how much we are spending, and this is in trillions of dollars, sometimes I like to keep it at zero. So you can see basically expenditure on fossil fuels is decreasing over time. Expenditure on the grid is increasing, and then there is what looks like an expenditure on non-fossil or renewables over time. That's going to go up. So if we want to look a bit more detail on that front, we want to see when is the sort of the tipping point here where it goes, where there's more money being spent on renewable or non-fossil versus fossil. So I'm gonna create another little line chart. Lots of little line charts. again drop the year in the x-axis, and we want the expenditure on fossil fuel and expenditure on non-fossil fuel, and then we want small multiples by expenditure type, which if I drop up here, expenditure type, small multiples, change this to, so you want to see CapEx, so capital expenditure on projects versus operational expenditure. So we see that fossil fuels CapEx is dropping over time, and the CapEx for renewables is increasing over time, but the operational expenditure for fossil fuel is still high over time, which may potentially indicate that it's costing more to operate fossil fuel energy plants or resources than it is to operate renewable type, but that's me maybe speculating a bit too much. Again, one more, maybe just to look at we want to look at the grid energy expenditure and fossil fuel and non-fossil, maybe just in a little bit more detail over the years. You just want to maybe look at it in a different way. I dropped in year in there. We want to drop in the energy economics value, expenditure type in the legend, and then we want a small multiples by the type. Sorry, small multiples by type. All I want fossil energy expenditure, grid energy expenditure, and non-fossil energy expenditure. The years. Again, we don't want to see all the years, maybe just a set. Sorry, yeah, there was an issue there. There was the color. I think I had one of the colors was nominated as white maybe, so it wasn't showing, so I just changed the CapEx and the OpEx. So hopefully this answers some of the high-level questions. I might just jump into EVs as the last one, and then I'll wrap it up. Okay, so jumping into the electric vehicle outlook, which may be of interest to some. Obviously we've got the market share, and then what I want to do is just another quick calculation of the non-market share. We'll see why. All right, so we drop in a stacked bar chart in here. Initially I want to turn off the filtering here because we don't have regions for this value. Okay, so drop in the dates. We have an EV market share, and then another one for a non-EV market share. But this is adding up different types of vehicles, so we'll drop in this, which is looking at the different types of vehicles. Sorry, I just got this one wrong. So if we want to look at if we want to see the split for commercial vehicles, you know, what's the uptake in EVs? It's a little bit slower than, for example, just normal passenger vehicles, and then even slower than two-wheelers. So two-wheeler electric vehicles are gonna come to the fore much more. Let me just drop in a line here, maybe just to see the 50% mark, so you can see. So around the middle of this decade, there's going to be more electric two-wheelers than fossil fuel ones, and then maybe early part of the next decade there'll be more electric passenger vehicles, but then commercial vehicles is going to be a bit slower on the uptake, because I think it's going to take a while for trucks and larger vehicles to come on board to get that type of fuel range and things like that. Okay, so next what I want to do is look at vehicle stocks. Okay, so we want a little line chart up here at the top. Again, drop in year, drop in the total vehicle stock, and then for the vehicles, EVs, let's see, EV stock, we want the variable as a legend. Okay, so we'll see here we've got these BEVs, which is what you might understand to be just a normal battery electric vehicle. We've got the FCEVs, this is vehicles that are using a fuel cell. ICEs, which are the internal combustion engines, so your diesel and petrol cars or vehicles. And then we've got the PHEV, which are this sort of plug-in hybrid type vehicles. So we see those plug-in and fuel cell numbers are fairly relatively small, but we'll see over the next sort of 10 to 12 years the stock of internal combustion vehicles is going to drop reasonably dramatically, and the uptake of electric vehicles is going to increase more. And you can look at that again across different continents or regions, what's going to happen there. If you look at Europe, that's what's there. Then we might want to look at just again a couple of big numbers. I think we've got vehicle stock. Let me just check here. Total vehicle stock, if we want to see what that's like, even just you know, at the end of the sort of period of 2050, you want to look at maybe something like the population of those people, or population of people living there. Let me see. Have I got, where's my population? So population, drop in there, and then maybe you want to look at, you know, what's the number of vehicles. You want to look at the number of vehicles per population. So 0.48, and then my final graph or chart or viz will be just to look at that sort of over time. So again, drop the year in the x-axis. I get the vehicles per population in the y, and then that variable on the EV. Let me see where it is. It's in here. Let me just make sure I've got this right. So my IC is picking up the right number. Okay, so the colors, even though it's maybe not the best, are kind of aligned. So if I want to look at Europe, I can see that drive in reducing the number of ICE vehicles towards 2050 is coming down to a very small number. But I also see like the overall number of vehicles will reduce slightly over time. Again, you can see places like Latin America, number of vehicles is actually going to increase over time. Even though there's maybe a slower uptake in electric vehicles, you might want to look at somewhere like China. This is probably even more aggressive than Europe in terms of their uptake, and they're sort of phasing out of the ICE vehicle. You might want to look at North America as well. Again, there's a decrease in the number of vehicles per person, but we still have a reasonable percentage of ICEs even at the end of 2050. And you look at somewhere like sub-Saharan Africa, where there's going to be quite a significant increase in the number of vehicles, even though it's still a relatively small proportion per population. If you're a company looking to sell electric vehicles in sub-Saharan Africa, maybe you put that off for a bit of time because the demand is probably not going to be there. It's probably maybe down to the supporting infrastructure and things like that. So this type of information you can use to sort of maybe target where you think there's going to be the demand for vehicles, and whether you're a vehicle supplier or someone who's providing resources, you can sort of use this to maybe think about how you're going to pivot your business. Okay, so that was sort of very maybe slightly rushed, but a brief overview of if maybe some analysis you want to do at the front end of looking at energy and resources, seeing where where energy is being used, what the demand and supply sort of metrics are in terms of the types of energy. When's there going to be a transition, or when's the tipping point in the future? And so you can maybe plan for that. You might want to look at the economics about, how much is going to be spent, or what's the expenditure. And then also you might want to look at particular industries. As an example here, electric vehicles, but you might want to look at things like hydrogen, or, nuclear, or, anything else in between. You might want to focus a little bit more, but this is just a sort of maybe an interesting example for those that are looking at, what is the trend for electric vehicles in the future. So thanks again. Hopefully this was of some use or benefit, and maybe give an insight into maybe the front end business development side of energy and resource.